Thank you, Peter. Yeah, one day in advance. Good to be here already on stage. Gives me the opportunity to tonight drink an extra glass of wine. Um, so indeed, David Ariens. I've uh, I've started as an advanced control engineer, a data scientist, but very quickly I fell into the trap of the twilight zone. You know what I mean with the twilight zone? The zone where IT meets OT, where we all talk about it. We don't really understand that one. Now, I'm not really an OT guy, although I understand plant automation. I'm also not really an IT guy, although I understand, I would say, most of the technological advancements taking place. But I figured out that combining those two is becoming more and more importantly. Now, 10 years ago, when we talked about IT-OT convergence, was more a bit a technical convergence, right? We wanted to, I would say, use each other's networks. We wanted to use each other's computers. But nowadays, when we talk to when I talk about IT-OT convergence, it's really the accelerants of starting to use data at scale. And hence the presentation I'm giving you, the great unlock. How can we actually unlock all the data the presenters before me already have talked about? In this presentation, I'm not going to talk about any technical stuff, maybe a little bit at the end. And I'm more going to talk about the cultural stuff, the why, the how. So I'm working now, I'm managing Analytics for Industry. Analytics for Industry is a Viva Select sister company, as you like it, which means that I'm talking to our customers on their data problems. And when our Viva Select colleagues they face an issue, when people want to talk about how can we become data driven, how can we implement a data platform, maybe even talk about stuff like unified namespace, then that's where I come in. And so my job so my day job is this. And a while ago, a year ago, I was visiting a customer, and I was in this real, true IT-OT meeting, where on the one side of the table, there were the OT engineers, the ones who were responsible for, they had a PI system, they had a Viva historian, and so on. On the other side of the table, there were IT people, IT architects. That company, they had a vision to really build a data lake driven by IT. And I was sitting a bit in the middle. And all the terms came across. Azure and Databricks and Snowflake. And there was also a lot of misunderstanding. When we talked about asset structures, when we talked about data contextualization, then the people from the IT side, they also started talking about contextualization, about structuring. And it felt like we were saying the same, but once we just, I would say, once we went a bit deeper, we actually understood that we weren't understanding each other at all. We were actually talking a different language. And during that conversation, I came to the conclusion that although I've been working in that area for quite a while, I sometimes felt it was difficult for me to actually make that bridge, to actually understand the language of both sides and being able to connect the dots very well. And that's why during the night, I started writing the IT-OT Insider. It's a blog about the why and the how. It's a blog about converging. Yeah? And I actually really, I would say, kindly ask you to, why don't you subscribe to it? For three very important reasons. One, I think the content on that one is very interesting for all of you. I'm getting quite a lot of feedback from the community, and that also helps me improving my messaging. And bear with me, this is not an Aviva blog. This is agnostic. This is about the why and the how, not about the what. Now, two, because I actually have a present, and I brought a couple of books which changed me as a person the most. A couple of years ago, I read a book called The Phoenix Project. Has anybody read that book, The Phoenix Project? I see a couple of hands. It's actually a book which I would say it was the beginning of DevOps, of a way of working in IT where so you started breaking down silos, where on the one hand, in the past, you had developers, and on the other side, you had people from operations, and there were a lot of disconnects. This might sound familiar to you now. And I don't know, 10 years or so ago, in the IT, there was this new way of working called DevOps. And the Phoenix Project is a very, very good novel. And when I read that one, I actually started, I would say, using these concepts and applying them to our world. I have two books with me. People who subscribe today, you are in a chance, and I will randomly pick two names out of it, and you will get it today from me. I haven't brought it here on stage because I was actually planning to bring that book on stage tomorrow. But it's in my hotel room. And then the third reason is I actually made a bet. I have a co-writer. He works for Solvay. And he said to me, if I can get 50 subscribers extra today, he's going to buy me a bottle of champagne. I do like a bottle of champagne. So what are we going to talk about today? All the presenters here, you as well, as a customer, as a partner, we talk about all these new technologies. Knowledge capturing, we talked about teamwork, advanced control, analytics, building data platforms. We talked about Data Hub, we talked about the PI system. And they have something in common. And that one thing they do have in common is that a lot of the things we do, unfortunately, today, somehow gets thrown in the garbage bin. Now, I'm a bit exaggerating, I understand that. So what do I mean with that? So when we talk about digital ideas, when we talk about implementing fancy AI algorithms, if we talk about digital twins, if we talk about whatever new technologies around, then it starts with a simple fact that you probably had so many ideas already which never actually got executed, right? You have the idea and then you come to the conclusion, right, okay, this is too complex. Let's just forget about that. So that's number one problem. Number two problem is that depending on the source, I have my own experience, but there are a lot of sources in the world as well. We see that more than 70% of those projects fail. Even some talk about 80 to 90%. Now, what is failure? You have two types of failure. You have positive failure and negative failure, right? Positive failure means, in my humble opinion, that you're trying out something new, and you apply this fail fast principle, where you try something out, you come to the conclusion that it's not working out as you expected it to work out, and you stop the project. Meaning, we learn something, and we're not losing extra money. Now there is also the negative failure, and that happens quite a lot, where you have this idea, and it's also a bit the more, I would say, the more old school way of thinking, where we made a decision to invest in product A, B, or C, and we will keep on working on it until it actually, solves the problem it needs to solve. But that gets you, and then in this case, this is the 70% plus. Well, what you get there is that in a lot of cases, you just keep on throwing money and resources at it, and at a certain point in time, you will also just call it a day. Another problem you might have faced, well, I did actually, is this infinite proof of concept phase, where we seem to go from one proof of concept to another proof of concept to another proof of concept without never actually putting something into production to make an actual service out of the things we were introducing. And finally, if we actually get there, we do see a lot of scaling issues where the POC was easy, but then scaling from 1 line to 100 lines seems to be very difficult. And there are a couple of things where they have in common. It is because, well, it starts with the fact that in many cases, the business, and I'm not meaning the technological people, but the people who run the business, they didn't answer the why question. They didn't really answer what is the problem we're trying to solve here? Because if we understand the problem we're trying to solve, it's also easier to allocate money and resources, to have management attention. But in many cases, we just try out a technology just for the sake of the technology. Now, if we did answer that why question, there is also the how. How are we trying to solve that problem? And Mike mentioned it this morning. In the, I would say, the operational world, we're used to working in a CapEx-driven mode. So we want to build something as fast as possible, as cheap as possible, to a certain norm. Now, if we go to the digital world, we typically don't really know what we are going to build. We probably, because we answered the why question, we probably know what the desired outcome is going to be. But in many cases, we do not know how we get there. That's where we start talking about agility. That's where we start talking about failing fast. I call this applying Industry 2.0 thinking to an Industry 4.0 problem. We try to build a digital solution the same way as we try to build a physical asset. A third thing is enforcing IT-OT convergence. Now, you cannot enforce IT-OT convergence upon someone. You can make them work together. You can't enforce people to work together. And I will come back to that later in the presentation. Fourthly, and this is actually perfectly in line also with what Martin said, is that it's still difficult to access the right data. I'm in a lot of discussions with clients where just getting that data, and not only talking about a trend, but also for data science people, also when we are implementing data lakes and all those things, just getting that data is typically already a gigantic endeavor. And finally, if we do get the data, the scaling is still a thing. Now let's start with the why question, and I will be trying to answer all of these points in the remaining of my presentation. So let's start with the why question. I, and probably you as well, we love to talk about what we are doing. And here is the list again. All cool stuff, all nice things. Now, where we as engineers might live in the what world, our business lives in the why world, right? They have something to do. And I think there are only 3 important things they are worried about. It's either increasing profits, it's finding and keeping people, talent, or ensuring their license to operate, think sustainability. And if we do a bit of a deep dive into these different topics, then, and I'm not going over all of them, but what we basically have is a situation where on the one hand our business wants to achieve something and we need to identify that. On the other hand, there is our technology. And there is enough technology. Yes, there are, of course, still advancements to be made. And yes, if we take today a look to the, I would say, the conversion zone where sensor data meets the cloud or the IT cloud world, there is, I would say, a lack of standardization. But if we remove that a little bit, then I think that technology is enough. It's our job to answer that how. Now, that how in the middle is what makes or breaks your digital project. It's about applying new ways of working, applying new ways of thinking. It's about being agile without having to follow I would say, an agile management course. It's about accepting the fact that there are, in the projects we do, there are more unknowns than there are knowns. Now, if you like to read more about this, go to the blog and I have a full article on this topic. The next one is on IT-OT convergence or enforcing IT-OT convergence. What I've seen is that where in many cases IT and OT are today working in silos, that's because there is no trust. There are no shared ways of working. There is only limited shared technology, and that's typically just for those 2, 3, 4, 5 interfaces where, yes, we need information from our ERP system into our MES system, but we still work separately. Now, if we enforce IT-OT convergence, that typically means that one side starts to claim. Now, in this middle picture, you see that IT starts claiming OT, which I don't say that that's always the case, but what I do see is that happens quite a lot. Why? Because people from the IT side, they have the idea that we from the OT side, we're a bit slow in adapting new technologies, or we're a bit slow in adapting new ways of working. So you get this thing where one side comes in and starts claiming the other, which only results in friction, right? Which only results in we know better. And then finally, that leads to divergence. And that's why I call this that the road to IT-OT divergence happens sooner than you might think. Now, what do we think is important, or what do we think is the answer here? Is that on the left upper side, you see a situation which happens quite a lot, where you have an OT department and you have an IT department, and in the middle, in the green, you have this IT-OT zone, which is just, I would say, for whatever is a limited amount of things, right? Something supply chain related, a few small data science problems, and so on. A way which actually works is to expand that green box. Instead of trying to have one side take over the other side, is to have this green box in the middle, is to actually accept the fact that the expertise in that zone is something specific, is something really important for your company, and to expand that green box gradually. And you have two types of expansion going on. On the one hand, you have technical convergence, and on the other hand, you have organizational convergence. Now, the technical convergence is the most easy one. It's also the one which I think takes the least amount of time. Technical convergence is about talking to each other somehow. That might be via a data hub type of approach. That might be something totally different. That might be by sharing compute resources. It doesn't really matter. That might be by sharing ticketing systems or whatever. It doesn't really matter, but that's the technical part. The most interesting, difficult part is your organizational convergence. That can only happen when there is a desire from the inside out to do so. You can't force people to like each other. you do have to have a mandate from your upper management as well. And those two things have to come together. Working on culture, working on ways of working. That's why I like the Phoenix Project so much. The Phoenix Project is a book which it is written from an IT perspective, but it happens in a manufacturing plant. So they talk about introducing DevOps in a manufacturing plant. And it's interesting to see that where IT has taken, it started with applying lean principles, and then those lean principles, they became agile principles, and those agile principles became, DevOps, etc., etc. Now, the good thing is lean comes from manufacturing, right? So why don't we apply those things we figured out so many years ago as well in our own, onto our own work? Now, very important is that while doing so, we need to preserve our own identities. Because you still have a typical OT scope and you still have a typical IT scope, and we have nothing to do with each other. So let's make sure that we preserve that as well. Here as well, we have 2 full articles on this topic on the blog. Our next point is the fact that it's difficult to access the right data. There are probably a couple of people which were in the room last year when I also presented the digital journey model. I'm going to do that again because it's more relevant than ever. It is because we still see a couple of steps we need to take, and I'm going to walk you through them very quickly. Step 0, the dark ages, the data dark ages. We have SCADA only, we have paper only. The first step in which most of us are in this initial visibility phase where we've introduced an historian, we introduced Excel exports and trends and so on. And that means that the thing we have to do here is make data available for as many people as possible. Okay, good. I think most of us are in this step 1. Also, when I go to companies and I ask them, in which phase do you think you are? Most of them answer 1 and some 2. Because what is phase 2? Phase 2 is a discover or the diagnose phase. Something which it's a complete difference between just having raw sensor data and being able to diagnose them. Diagnosing problems means that we need to have structure and context. Structure means it's not just a flat list of tags. Context means we know when a production order started and stopped, and etc., etc., etc. We know about market conditions and so on. We can actually attribute something. We can actually attribute a measurement to something which physically happened in the plant. Having that context, having that structure available is, I hate the word game changer, in the sense that this now gives the possibility to everybody in an organization to build their own reports. They don't have to have the technical expertise anymore to combine all those data sources. Okay. Then we go to the prediction, the first AI models. Instead of diagnosing a problem, we get informed about the problem, preferably in advance, right? Now, one of those things where we see most problems coming in when we go from a diagnose phase to a prediction phase is, I assume we already have data connectivity figured out, is data quality. Because when we have a dashboard and the KPI number is always around 90% and suddenly it's 9,000%, then the person who reads the dashboard knows, okay, the data is rubbish. But once we have automatic models which uses our data, then we spend quite a lot of time, either manually or automatically, in fixing data quality. And finally, if we have that done, then we can go to an optimize phase or a close the loop. Close the loop means that we're feeding back those predictions into our automation systems. And in this case, the business context is becoming really, really important. With business context, I mean, understanding what business decisions I need to make. Do I need to have optimal efficiency? Do I need to have minimum energy cost at this point in time? Maybe a decision can even be to shut down a line for a while because we are not running at a 100% utilization rate. All those things which a human could know if he or she has the right context. We need to be able to get that information if we go to optimize. Now, there is an interesting thought here, is that, and I had a discussion actually beginning of this week, where does it become more and more costly once you go from step 1 to 2 to 3 to 4? And some people might think, and I actually also had that intent at a certain point in time, that the more you go to the right, the more costly it is to implement those things. But I don't think so. Because if you take every step after another, then basically by taking a first step, you enable the next one. If your data quality is in order, then building machine learning models becomes much easier. If you have data available and contextualized, then building dashboards becomes very easy. So it's actually a more gradual model. But the value, of course, increases quite a lot. All right. One thing which I didn't mention is the importance of data platforms here. The time where we all needed to access separate systems, that's long gone. Well, long gone. I still see that quite a lot. But having the availability of one data platform for all your sensor data, maybe even combining it with more IT or ERP data, that actually becomes an actual game changer to really speed up those steps. But then we still come to the scaling issue. I already mentioned data quality. We still come to the scaling issue because, and I have a couple of examples here where you see some raw sensor data at the left where we have noisy data, where we have flat lines, we have some undersampling spikes. I just named a couple of things, and I do think most of you who worked with data can relate to those. And that's already a problem, but that's on the sensor level or the interface level. Once we start building data pipelines, we are typically enlarging those problems, where we sometimes lose data while it gets transformed or transferred. We have late data to incorporate, timestamp misalignments, you name it. The pipelines we're building today are also becoming more and more complex, especially where we build something in a data science environment, maybe on some cloud environment where we have to extract data, where we have to transfer it, where, yeah, maybe we do some manual cleaning, maybe we do some manual enhancements, and so on, and so on, and so on. And the question is your final report trustworthy? Does it actually resemble the correct data, well, the data we had at sensor level, even knowing that data is also probably incorrect? And do you look to all those hundreds and thousands and 10,000s of sensors to actually understand whether or not they're working? To summarize, I did talk a bit about the why, the how, the fact that the IT-OT convergence problem, the difficulty to access the right data, and difficulty to scale. But I also gave you a couple of potential answers. Now, I can't answer your why, but I do hope that within your companies, this is getting more and more important. Before we try technology, that we understand why we are trying technology. I can't answer your how, but I can also give you a couple of ideas on how to do this new style, on how to use I would say, the advancements in ways of working in culture we find at the IT side and apply that to the OT side as well. We can expand the box for IT-OT convergence. We can have a data platform first approach. And for overcoming our scaling issues, we can work on profiled and verified and protected data. And with that, you will certainly enjoy the great unlock. Thank you very much.